So for example, this one could have been expressed as if rating equals G and age less than 12, but we separated it into nested ifs. And why might we do that? Because it was a little bit more specialized. It was not just an either one thing or the other, right? We got lots of different choices here. If we collapse these inside with an and, if rating is equal to G and age is less than 12, we'd only have two possible paths. Here we got lots of different possible paths. So it was better off nesting it. I haven't asked y'all to do homework with lots of nested ifs and ors. The case structure. Have I talked about the case structure? Feel free to say no. It's because our language doesn't support the case structure. Let me show you what it looks like, and then you can delete it from your brain until you take Java or C++ or something like that. So are we on Q? It looks like elemental PQ. All right. So here's what a case statement looks like, a switch statement. Say we did this, and Python doesn't have it. Like we get X, and then we switch based on the value of X. And if in case the user typed in a 1, we do something. If the user typed in a 2, we do something else. If the user typed in a 3, we do something else. If they didn't type in a 1, 2, or 3, it goes to the default clause. And I don't care if y'all type this or not because it's not in our language, right? Print, blah, 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 right? Okay, there we go. And that's the end of the switch case statement. I don't know why the guy who invented Python didn't put that in there, because it's really kind of a nice way to do it, right? It replaces a whole bunch of ifs, elif, elif, elif statements. It's a very concise way of doing it. Now, people don't always tab it that way. They usually do it like that, but still, kind of nice. And in those languages, you then put a break statement there, and a break statement there, and a break statement there to indicate that it was not supposed to do the next case as well. Because without the break statement, it would do 1, and then it would fall through and also print out that. And if this break statement was missing, it would also fall through and do that. And so usually you don't want that, so you'd always put a break. All right, y'all have now seen a switch case statement. Not going to be on my exam. If it's in the Mind tab, then just look it up in the book, get it right, and then learn about it again when you take Java or C++ or something. And that is about the end of the chapter. If you were going to flowchart a case statement, a switch statement, it looks like this, right? This is a switch. I wouldn't write switches. I would actually put the word switch in the diamond, but you know this book doesn't like to put ifs and whiles and stuff like that. I'd put the switch there, and then I would list all the cases here. We don't need to do that. We're not drawing any. Just like for you to have the idea tucked away in your brain, though. All right, so our summary. Decisions are based on Boolean expressions, which are things that become either true or false. If temperature is less than 0. If age is greater than 18, right? That's either true or false. You can use relational operators to compare values. Ands mean that both conditions have to be true. Or means one or the other. If you're doing an and decision, you want to ask the question that is less likely to be true first, right? This is a college. Almost everybody is over 18. So if we needed something that said if age is less than 18 and you attend high school in this zip code, right? Well, This one's going to be less often true, the first one, right? Lots of us attended high school in this zip code, or at least in the surrounding area, right? But not many of us are less than 18. So you'd want to put that one first so that it would rule out the second check. That's more efficient. The user would not have to type in both, that they were less than 17 and what high school they went to, because we don't care what high school you went to if you are not less than 17. Silly example, but hopefully that makes sense. Or means one or other condition needs to be true. I am sick or tired. And in that case, you want to put the one that is more likely to be true first, because then it will eliminate the need for the other one, right? If I'm sick a lot more often than I'm tired, I'm not going to ask if I'm tired first, because if I'm not tired, I still have to check the second one. I still have to see if I'm sick. But if I put the one that's often more often true on top, then we can eliminate the second check. I am tired more often than I'm sick, so I'm going to ask to see if I'm tired first, because if I'm tired, I don't even need to ask if I'm sick. For a range check, you check the lowest and the highest values. If you're checking inside the range, you use AND. If you're checking outside the range, you use OR, right? If test score greater than 0 and less than 100, right? Some slightly variant of that. I use less than or equal to greater than, right? If it's greater or equal to 0 and less than or equal to 100, then print, valid test score. We used AND because we were checking within the range, 0 and 100. We use OR to check outside of it. If test score less than 0 or test score greater than 100, we're checking to see if it's outside the range of 0 to 100. And since it's similar to multiplication, if you look at the binary chart, it takes precedence, has higher precedence over OR if you write an expression that has both ANDs and ORs. And that can be one of the things that make writing expressions that have multiple ANDs and ORs in them difficult. Computer doesn't care, but we better get it right. And the case structure, specialized selection structure, that where you list all the separate cases instead of writing if, elif, elif, elif. Or if, else if you're using another language other than Python. All righty, any questions before we hit chapter 5? Looping. Well, we've already been doing looping, so this isn't going to be too bad. We haven't done a lot of loops. We're going to do more. We'll learn everything there is about looping now. I think I've said this before, but if you understand the idea of looping and you understand the idea of modules, then you're already a programmer. An honest-to-goodness programmer who understands the fundamental concepts of programming. There are lots of other things to learn too, but those are key because programming involves so many loops and the writing of so many modules to modularize your code. Any program that's more complicated than just inner temperature and calculating Celsius and printing Celsius is going to have modules and loops in it. So the advantages of looping, using a loop control variable, nested loops. All right, let's get to it. Why use loops? Makes computer programming efficient and worthwhile. I like the term worthwhile. Programming isn't worthwhile without loops. Okay, that's kind of silly. Makes it efficient. You're not copying and pasting code. If you're calculating the radius of a series of circles, or you're calculating the the worthiness of somebody to get a low interest rate loan, it's better to put that in a loop rather than to just say, okay, is person 1 worthy of that loan? Is person 2 worthy of that loan? Is person 3 worthy of that loan? What if you have 10,000 people to evaluate? You don't want to have that evaluation statement 10,000 times in your code. You want it one time in your code inside of a loop. So you can write one set of instructions that operate multiple times, multiple sets of data. Makes it shorter compile time, right? Because we have only one statement doing that evaluation of low interest rather than 10,000. Less time is required for design and coding. I didn't have to type in that statement 10,000 times or copy and paste 10,000 times. And fewer errors. because I can figure out that the logic is correct. And I didn't make a mistake on calculation 5,321, right? I only have to get it once inside the loop. I get it correct once inside the loop, and I'm halfway towards making sure the program works correctly. So a loop is a repeating structure. Keeps repeating while a condition is true. While x is greater than 0. While guess is not equal to the secret number. While not correct, right? Keep repeating. If I went back to Monday's code, one of the things I might have done, if I had time, is to make it so that it would loop and ask me if I want to play again, right? Rather than make it have to run it every time. And I could have done that by enclosing, where'd it go? Oh, it was lecture P, excuse me. Right. Do you want to play again? That's what I need to do. So down here at the top of our game, right? Play again equals quote y, right? And don't go back and modify your code. This is just conceptual. While play again equals quote y. Keep repeating that as long as that variable is like that. Tab all that stuff over. And then down here we're going to ask them if they want to play again, right? Play again equals input, parentheses, quote, do you want to play again? And then we have one more int while here. All right, now I'm going to cheat and make this print out the secret number because I don't want to honestly play the game. All right, just want to show you that part. All right, well, I have another guess, right? 50. Nope, it was too high. 25. You got it. Do you want to play again? Yeah, sure. Yes. What's your guess? 50. 12. All right, you got it. Do you want to play again? Nah. And it ends. So we enclose the entire program inside a loop. Now, how would we have done that without a loop command, right? We would have had to like copy the entire program and then, you know, paste it down so that they could play it a second time and paste it down again so that they could play it a third time, something like that. It'd be insane to try to implement that thing, do you want to play again, if you didn't have the ability to loop. Old school arcade game, right? If you have a quarter in it, if it's got any credits left, you can press the start button. It's got a loop, checking to see if you have any credits in the game. If you don't have any credits in the game, it goes into another state. It's outside of that loop. If you do have a credit in the game, it's inside another loop waiting for you to click the start, the player 1 start or the player 2 start. You finish that, now you're inside that loop that's playing the game. You finish that game, it deducts 1 from your credits, right? You played a game of Pac-Man, you had 2 quarters, now you only have 1 quarter. You can still press player 1 start. You're still inside that loop. Finally, you run out of credits and you're outside of both loops and it's in another loop waiting for, you know, somebody to insert a quarter. So the logic for that would look something like this. You know, while the game is on. Now that's a silly way to put it, right? But, you know, while true, run forever. The game is going to run forever until it is unplugged, right? And then we need to check to see if we have any quarters, right? If we have credits. While credits is greater than 0, right? While we still have lives left as on Pac-Man, right? While Pac lives is greater than 0. And then play the game. And then reduce Pac lives by 1. Once we're gone, the game is over, we check to see we have to reduce our credits by 1. And then we're waiting for them to put in more quarters. So this is the end of the credits portion. So now we're waiting for more quarters. Right. And there's more involved than that, right? We got to wait for them to press the start button. That could be here, right? So while not start button, wait. Right? And then as soon as they do press the start button, then we start playing the game until they run out of lives. And then the game is over. We remove one from the credits. If they had 2 credits, now it's equal to 1. We come back up to the top. Credits still greater than 0, so we wait for them to press the start button again. We play the game. They run out of lives. We subtract 1 from the credits. Now we've used up all of our quarters, and so it comes down here. And this probably is a loop up here. While, quarters, or while credits is equal to 0, wait. Wait for adding a quarter, right? Lots of loops, right? Lots of loops just to get Pac-Man to be a playable game. And that's just the bare structure of it, right? That's just a simple skeleton. It's not drawing things on the screen or whatever. So nested loops. Nested loops are where it's at. That's why I say that once you get the idea of looping, then you're a programmer. All right, they claim that a looping is a dual alternative thing. I would argue with that because we saw previously that dual alternative means take 2 branches and then join together. Here we've only got 1 branch and then it repeats. I guess the other alternative is just falling out of the loop. I don't like saying it's a dual alternative. If it asks that on MindTap, yeah, go ahead and pick the dual alternative answer from the quiz, but I'm not going to ask that. But we see the structure of it. If this is true, if that's true, while x is greater than 0, while credits is greater than 0, play the game. Then remove 1 from the credits, come back here. While credits is greater than 0, it's no longer greater than 0, so fall through. So as long as the condition remains true, it keeps repeating. While our number of credits is greater than 0, it keeps letting us play the game. While Pac-Man's lives are greater than 0, it keeps restarting and he gets to move around the maze. While the number of dots on the maze is greater than 0, we keep playing that one. When the dots on that maze hit 0, it's out of that loop. He's eating everything on the screen. I hope y'all know what Pac-Man is, or else this isn't going to make any sense. Right. Once he's eaten all the dots, the while dots greater than 0 loop exits, so it can draw the new screen. And then go back and do it again. So to control the number of repetitions, there are a couple of different kinds of loops. There are definite loops and indefinite loops. Definite loops repeat a certain number of times. I'm adding up all the numbers between 1 and 100. That's a definite loop. We know we're starting at 100. We know we're starting at 1 and we're going to 100. And then there are indefinite loops. You don't really know how many times it's going to repeat. Right? In a game, you might earn extra lives. Right? And so your statement, while lives is greater than 0, well, sometimes lives is being increased, right? You got more than 20,000 points, you get an extra life. So you don't really know how many lives they're going to have before it ends. That's an indefinite loop. Or how many times they're going to type in yes because I want to play again. They might not want to play again at all. They might want to play again 1,000 times. They're really obsessive about it. Right? So that's an indefinite loop. To control the number of repetitions, you use what's called a loop control variable. And I haven't made y'all type in any code yet, so let's go ahead and do an example. In my notes with a triple quote. All right. Definite loop. We know how many times it's supposed to run. Or we are stepping through a set of data, right? We have a list and we're going to go through every item in the data. right? Like this. X is equal to 0 while x is less than 10. Print x. That's a definite loop. So definite loop
Question, sir.
can be a counting loop.
Question, sir.
Yeah. When I finish typing that. Yes, sir.
Should this be like lecture
Q's.
Q?
My understanding.
Or are we continuing on our old, because you're doing this?
I made some changes to the other program, but I then closed that document.
Okay.
Yeah. Right. This doesn't really, that doesn't have the guessing game, right, in it. You don't have to include the guessing game change if you made it in these notes. If you feel like it, copy and paste it or append this to the other one and rename it. Save as. Lecture Q. So that's our counting loop, definite loop, or if we're going to step through a series of values. A for loop is a definite loop. For x in range, parentheses 0, comma 10, adding 1 to it each time, print x again. That's another definite loop. We're stepping through a series of values. And we're going to do one more kind, which is another variant where we declare an array. I'm going to declare my array, and I'm going to call it L for list because that's what Python calls it. But everywhere the book says array, we can think in list in Python, and everywhere in Python we say list. Think of it as a book calling it an array. Okay, so I'm going to print something out. I'm going to print some numbers out. 100, comma, 200, comma, 50, comma, 1. Right, that's my list. It could be 10,000 elements long, but it's a definite loop. We already have that data before we go in the loop. For x space in space L colon, print out x. Those are all examples of definite loops. 2 of them written with for, and 1 of them written with while. If at all possible, write all of your definite loops as a for. For is designed entirely for definite loops. That's its purpose. Whereas while supports both definite and indefinite, but it's the only way to get indefinite loops to work. So let's run it. And I made a mistake. This is one of the reasons why you should use for loops for your indefinite loops. Because I forgot to update it. I forgot to add 1 to x. So back to my while statement, x plus equals 1, or x equals x plus 1. So this is called the loop control variable. Right there, that x is equal to 0, that's the loop control variable. It's a variable that controls whether the loop runs or not. We had another loop control variable in our guessing game called correct, I think. That's a loop control variable because we kept looping until the game was correct. And so your 3 steps of a loop. You have to have a loop control variable. You have to have a body, something that the loop is doing. And then you have to have an update of the loop control variable. LPC, loop control variable. Our guessing game did all this, right? The game was not complete, so we set complete equal to false. I forgot something. Delete this. We could leave that there. But really, when the book talks about it, it's step 2 is the condition. Sorry about that. And then, of course, you also have to have a body. And then 3, the other super important thing of it, I've renumbered these because that's how the book categorizes it. So we did this in our guessing game. Correct is equal to false. While correct is equal to false, or while not correct, then we played our game. We asked them for the input. We compared it to the secret. That was the body of it. And then, if they ever got it right, we set correct equal to true. We updated the loop control variable. That should have been LCP, right? Loop control V. I don't know why I came up with those other letters. My brain glitched. loop control variable. Right? If you do not have an update to the loop control variable, it's going to repeat forever. Now there's a way to jigger it so that it doesn't repeat forever. You could have a break statement, or you could have a return statement. We haven't hardly ever used return yet. We really haven't used break much. So in general, you got to have those three steps. And even if you have a break statement in it, it's got to be triggered based on some condition. So those are the three parts of a loop. Using the loop control variable, having a condition, and updating the loop control variable. We even do that with a for loop. The loop control variable is x. The condition is that it's between 0 to 9, or it stops when it hits 10, that's the condition. And then that's the update as well, right? Going up by 1. So although the for statement only has 2 lines of code rather than 4, looks a lot more efficient, it's still doing all 3 of those things. And it's also got a body, so it's really got all 4 of those things. Let's run it, make sure it works. I've talked a lot about it, but I haven't actually run it. All right, so it printed out 0 to 9 2 times in a row, and then it printed out our list, our array, 100, 250, and 1. Those are all example of definite loops. The first 2 were counter-based loops. The next one was a list-controlled loop. Same idea, though. It's stepping through a series of pieces of data with the for statement. So your repetitions can be controlled by a counter, right? X is equal to 0, X is equal to 1, 2, 3, 4, 5, or it can be a sentinel value. A sentinel value marks an indefinite loop. Do you want to play again? Yes, no. That's a sentinel value. Those are worthy of putting in our notes, and then maybe the last notes we take. Don't think there's going to be any homework. I want you all to take the quiz. If you haven't taken Chapter 4 quiz, that's your weekend homework. All right, so loops controlled by either a counter, I think that's what they called it, yeah, which is a definite loop, or a sentinel value, which is an indefinite loop. And our counter in all the examples up above was X. And our sentinel value in our guessing game were whether it was complete, whether play again, was set. These are just examples from the guessing game. They're not going to be mentioned in the book, but you get the idea, right? Keeps running until it's complete. Keeps running until play again is no longer equal to yes. So our sentinel values are when complete is equal to true, or when play again is not equal to yes, right? So when play again equals no. Those are our 2 sentinel values in the programs that we've been talking about the last 2 days. Good enough. Let's stop there. So we stopped on page 6. Make a Dropbox, and then we'll check to see if anybody has any typos that you want saved.